Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shukri bin Amzari. I'm a student of Mechanical Engineering from UiTM Shalam. So I'm going to present my final year project. Alright, the topic I choose is generative design of additive manufacturing components. What is generative design? Generative design is a technology in which 3D models are created and optimized by computer software. Meanwhile, additive manufacturing are the process of creating an object by building it one layer at a time. So, for the process of the generative design, I choose is topology optimization. This is the example of the generative design. Alright, topology optimization. Topology optimization is the mathematical method that optimizes the material layout through the material reduction while maintaining the maximum thickness. So, when the material is reduced to make some components, it will reduce the cost also. Next, okay, the problem statement of my proposal is many parts of the airplane that only carry the unnecessary weight. For the example is the aircraft seat leg. This part of a component can be optimized to reduce the use of material for its production. Okay, the objective is to develop optimized selected component using topology optimization, also to reduce the weight on the component. Okay, scope of project and limitation. This is the picture example of the aircraft seat, and at the bottom you can see this is the seat leg, the blue color one. Okay, the scope project is process that I choose is topology optimization. The components are the aircraft seat leg. Material used is the 7075 aluminum alloy, and the software I will use is Inspire. And the limitation of this final project is it will be conduct fully simulation because of the pandemic COVID-19. Alright, next, methodology. Okay, this is the flowchart of my methodology from the start until the end. This is background research, design 3D model, structure determination, topology optimization, simulation, and validation of the result. Okay, the first one is background research. Okay, we will do a research on a previous study regarding topology optimization to identify the scope of project. From there, we can come up with a product to design and materials to work with. The result of this test is the component I choose, aircraft select, and the material we will use is 7075 aluminum alloy. Okay, next is design 3D model. Okay, the first step we will download the Inspire, and then in the software we will choose the sketch module, and we sketch the 3D model, for example this picture, and we will split part for the design and the non-design part. Okay, next is structure determination. Okay, we will apply the load and support on the model at the non-design part, here at the gray one, at the light color parts. Okay, then we will apply the load. The load is the arrow, the red arrow, 1 Newton at the multiple direction. And then at the rear part to mount at the floor, we will apply support, the cylinder, the red cylinder one. Okay, next process is topology optimization. Okay, we will see before and after the simulation run. We will choose 50% at the software, and then if I remember, I choose the minimum stiffness, minimum thickness. Thickness is about 0.05 meter. Alright, the last one is validation of result. Okay, the result obtained, the accepted part will be analyzed. The comparison between before and after simulation will be made. Okay, for this product, the design MS will be considered. Okay, we will see from the design earlier, you can see that the mass is greatly reduced. Okay, this is the analysis from the software. At the beginning, the weight is about 7.6 kilogram, and then after simulation, it has been reduced to 4.04 kilogram. About 47, about 46.79% of the weight can be reduced. All right, that's all from me. Thank you.